Good morning, everyone, and thank you for attending today's webinar. My name is Jim Johnson, and I'm the NTech Polymers Director of Plastics Technology, and I'm also a Business Development Manager for the compounding market. I've been with NTech Polymers for 19 years, but have worked for plastic material suppliers for most of my career. I will be presenting today's live webinar on Polymeric Compatibilizers for blends and recycled compounds. A PDF copy of this presentation will be emailed to everyone after the webinar is completed, and you can submit questions in the Q&A chat box at any time during the presentation, but I'm only going to be addressing them at the end of the presentation. I need to show NTech's legal disclaimer, and you can read through it briefly right now, and you can certainly read it in more detail once you receive your copy of the presentation. It's basically stating that the information provided today is true and accurate to the best of my knowledge, but you need to use your own judgment if or when you apply any of the information you're going to learn about today. For those of you that may not be familiar with NTech, we're one of North America's biggest distributors of thermoplastics. Our product lines include commodity, engineering, high performance, and specialty resins, as well as elastomers, recycled and bio-based materials, and some master batch additives. We have 11 field-based technical service engineers that support our 90+ sales reps and our approximately 5,000 customers. We have 7 business development managers that support the compounding, automotive, packaging, and medical markets. And we also have several large logistics supercenters, as well as private and lease warehouses throughout the US and Canada to provide the best logistics support to our customers. NTech is the largest distribution company within the Ravago group of family of companies, excuse me. The Ravago Group has been a global supplier of plastics, rubbers, and chemicals for over 55 years and has more than 7,000 employees in over 325 locations across 55 countries. They supply over 14.5 billion pounds of materials from over 3,200 different suppliers to a customer base of over 50,000. Now that we've got that background information taken care of, I can move on into the presentation. So in today's presentation, I'm going to be giving a brief introduction to polymeric compatibilizers, how you use these compatibilizers, the general types of these polymeric compatibilizers, some of the considerations when you use them. I'm going to provide a compatibilizer summary table, and then I'm going to go through 8 or 9 compatibilizer examples before I get to the summary and move into the question and answer session. So what is a compatibilizer? One definition, it is any substance used to stabilize blends of immiscible polymers. But that could encompass polymeric or non-polymeric compatibilizers. And again, today we're talking specifically about polymeric compatibilizers. And these are polymers or copolymers that when they're added to that immiscible polymer blend, it modifies the interfacial character, promotes adhesion, and stabilizes the morphology. So that's what the polymeric compatibilizers are going to do. We'll often hear the terms compatibilizer and coupling agent, and they're often used interchangeably, and I'm even guilty of this, but they really have different meaning. Coupling agents are used to bond an inorganic material like glass fibers or minerals to the polymer matrix, whereas compatibilizers are used to bond 2 or more immiscible polymers together. Slightly different definition. And these coupling agents and compatibilizers, as I mentioned, can be polymeric or inorganic, but today I'm only going to be speaking about the polymeric compatibilizers. So the uses of these compatibilizers, when and where and why do we use these? Well, not only can the polymeric compatibilizers be used as a compatibilizer, they can also be used as a coupling agent and also as an impact modifier. And for the most part, the difference here is the loading level and the application. So as a coupling agent, we're typically looking at loading levels below 5%, with 1%, 2%, or 3% being very typical. Again, we're going to compatibilize or couple that inorganic material to the polymer matrix. With as a compatibilizer, we're typically looking at a range of about 5 to 15% loading, with 5, 6, 7% being fairly typical. You know, based on my experience and technical references that I've seen, you'll often hear that 15 to 25% of the minor phase seems to be the real sweet spot for a lot of these compatibilizers. So if you had a blend that had 30% of the minor phase, 20% of that amounts to 6%. So that falls within that fairly typical range. However, the loading level does depend on a number of factors, including what polymers you're compatibilizing, what is the viscosity differences of those polymers, what is the loading level of those polymers, and there's going to be some other factors that influence it. So the loading level range is going to be dependent upon your specific application. And if we increase the loading level of these even further, we can make them use them as impact modifiers. And so we usually use a range of about 5 to 30% for impact modification. And you'll notice there's some overlap with the compatibilization levels. But as an impact modifier at those very low levels, it provides really practical impact improvement. But if you need to improve notched IZOD impact values, you really need to be at higher loading levels, typically above 15% or so, to really start increasing notched IZOD impact values. And so we use these polymeric compatibilizers when we're making, compounded polymer blends. So maybe you're making a nylon polypropylene or a nylon ABS blend or a PET polypropylene, where you're going to need to compatibilize these dissimilar polymers. So that's a very, very big common area for compatibilization. We also use it in recycled compounds because you often have contamination or you have mixed polymer feed streams. And so in today's world, we see that there's more and more demand being put on post-consumer recycled materials. We're seeing that there's less and less availability. So I believe we're going to see a lot more lower quality feedstocks being used, these recycled feedstocks, and therefore it's going to really drive the need for compatibilization in order to utilize them. We can also use these compatibilizers at machine side. So one example might be if you're making multi-layer film scrap, we could include a compatibilizer to tie in those different polymer layers to be able to use it there. Now, depending on the type of compatibilizer, some of them will work better at machine side, some of them will not work as well at machine side. So it depends, again, a little bit on your application. And I have a note here that we also, in addition to using these materials as coupling agents, compatibilizers, and impact modifiers, they're also used as tie layers in multi-layer film or multi-layer blow molded products. Although in this case, we wouldn't call them a compatibilizer, we would call them a tie layer or an adhesion promoter, because again, they're not in a polymer blend. So what are the general types of compatibilizers? There's two primary general types, as we call them, and that is reactive compatibilizers, which are typically functionalized polymers or copolymers, and they're primarily functionalized with either maleic anhydride or glycidyl methacrylate. And then we have non-reactive compatibilizers, and these incorporate things like the acrylate copolymers, in some cases acrylic acid copolymers and ionomers, or block copolymers. And so if we first start with the reactive compatibilizers, maleic anhydride is really the most common type of reactive compatibilizer. And that's because it's so very versatile. Now, the maleic anhydride content can vary from very low, which is about 1/4%, up to very high, which is about 1.5%. And so depending on the loading level of that maleic anhydride will determine where it's used, when it's used, how it's used, and how it may perform. And that content varies within a given product portfolio, as well as obviously within supplier to supplier. The maleic anhydride tends to react with amines and epoxy and alcohol groups in the polymer. And many of these maleic anhydride functionalized materials are based on polyolefin backbones. They're also based on styrenic backbones, and in theory, we can functionalize many different polymer families. It's just that the polyolefins are probably the most common. In addition to that, there's products, polystyrene products that are functionalized with maleic anhydride. And what we're doing here is with the polyolefins, we're typically compatibilizing a polyolefin like polyethylene or polypropylene to polar materials like nylon, EVOH, polyester, cellulose, etc. If we look at the styrene maleic anhydride materials, these are going to compatibilize styrenic polymers to those polar materials like nylon, EVOH, and polyester. And then we have maleic anhydride functionalized styrenic copolymers. So these are things like SBS, SEBS, and other styrenic block copolymers. In addition to compatibilizing styrenic materials to polar materials, these can also compatibilize styrenic materials to polyolefins. So once again, we can see there's a range of products here that can be used to compatibilize different polymers to different polymers. The next most common reactive compatibilizer is glycinyl methacrylate. And just like the MAH materials, the GMA content will vary between specific grades of a polymer as well as from different producers. So you can't always compare apples to apples with these because you may have different loading levels of the GMA in one product versus another, and that will affect its cost for sure, but also its performance, okay? GMA reacts with amines, anhydrides, alcohol, and acid groups in the polymer, and we use these to compatibilize polyolefins to things like polyesters, nylon, ABS, and polycarbonate. We also use these in asphalt or bitumen compounds as a compatibilizer in those formulations as well. And I would note that GMA products functionalize polyester-based materials very, very well, and they would be the first choice of compatibilizer for use in those polymer systems. And now if we move on to non-polar polymers, again, these are non-reactive. Maleic anhydride and glycinyl methacrylate have chemical reactions that occur, so they provide very, very good bonding, very, very good compatibility between your two polymers. The non-reactive ones do not have a chemical reaction. And many of these are based on polar materials like acrylates, ionomers, and acrylic acids. And one comment, the acrylate materials are utilized extensively because they have generally good compatibility in a wide range of polymer systems. So they can work very effectively at compatibilizing polyolefins to a wide range of non-polar materials. And typically with these type of non-reactive materials, the compatibilizer backbone is typically compatible with or miscible with a non-polar material like polyethylene or polypropylene. And then the acrylate end tends to have an interaction, a polar attraction or weaker forces with your other polymer. And now if we look at block copolymers, again, these are non-reactive materials, but block copolymers have two or more segments of the backbone where at least one segment is compatible with one polymer and the other segment or the other block is compatible with another polymer. These products tend to migrate toward the interface between your two polymers, and they help to reduce the interfacial tension. And what that does then is it increases the adhesion between your two polymers. It can also provide for a finer dispersion in there and then therefore better mechanical properties. And so the very common block copolymers again include things like SBS, SEBS, other styrenic block copolymers, as well as olefinic block copolymers. And typically of the non-reactive compatibilizers, these block copolymers perform very, very well because once again, we have one segment that attaches to one polymer and another segment that attaches to the other polymer, and they bridge across that interface. So some of the considerations when you're thinking about using compatibilizers. If you're making a polymer blend, obviously you need to understand what are you trying to compatibilize? What are those two polymers that you're talking about in your blend? You might need to think about whether you want a reactive or non-reactive compatibilizer. Why is this important? Aside from the performance aspect, there may be a cost aspect to that. And one thing I didn't mention on the reactive compatibilizers is they do tend to have a very negative effect on the melt flow of your final compound. And so if high melt flow of the final compound is required and your application will allow you to use a non-reactive one, that might be something for consideration. Again, how much compatibilizer do you need? Once again, it depends on the percentage of the two polymers that you're blending and what those two polymers are. Because for some of them, some polymers are much easier to compatibilize, while other polymers might require higher loading levels to get good compatibilization. So that's something you need to consider. What is the level of the minor component? Well, obviously you know that, but that minor component might be 10% or it might be 50%. So obviously it's important to note there because the higher levels might require higher levels of that compatibilizer. The next bullet point, what is the viscosity difference between your blend components? This is a really important concept here because the greater the viscosity difference between the two polymers you're blending, the less compatible they are inherently. So when there's a great viscosity difference, once again, you might need to look at a different type of compatibilizer or different loading levels of the compatibilizer just to overcome that viscosity difference. And that's a concept that I see that a lot of people miss. They look at blending very, very drastically different viscosities of the polymers, and it just makes it a little more challenging to get really good compatibility at a moderate loading level and therefore at a moderate cost. How does a compatibilizer affect the mechanical or physical properties? Once again, most of these are based on polyolefins or olefin copolymers, so they're going to have a little bit of a flexibilizing effect, especially if you have to incorporate higher loading levels based on your particular blend. But in general terms, anytime you compatibilize those materials together, you are going to improve your mechanical properties, especially those characteristics like elongation, impact, and ductility. How does the compatibilizer affect the final melt flow? Once again, this is a big one, and this is where I see a lot of the challenges, especially when a reactive compatibilizer is the best choice for the polymers you're blending. But once again, it negatively affects the melt flow of your final blend. And there are some things that we can do. There are some tricks that we have that we can help with that while still getting good compatibilization, but trying to minimize the negative reduction in melt flow of your final compound. How will the compatibilizer affect your cost? Well, if you're making a polymer blend, it's going to affect your cost because it's an added component. However, once again, having a choice of multiple compatibilizers for your formulation, you can look at the cost performance of that blend and try to compromise to get the best performance at the lowest cost. I have a comment here on if you're using a twin screw extruder or a single screw, it's not quite as important when you're talking about adding it as a compatibilizer or coupling agent. But if you are also looking for some impact modification and you want to use higher loading levels, then twin screw extruders are preferred, or single screw extruders with a mixing zone. But once again, it depends if we're going to use a chemically coupled or a non-chemically coupled compatibilizer. And if we talk about using these in recycled materials, the real challenge there is that you might not know what the other polymer contamination is or what the contaminant may be, and you may not know how much is there. Now, once again, you can do some testing to determine what polymers are present and what loading levels they are in. That will give you a better opportunity to determine what's the best compatibilizer to use for that specific application. And as I mentioned, with more and more customers and end users wanting to use post-consumer recycle, the demand is so strong that I believe that people are going to start looking at some of these lower quality, lower cost feedstocks, but we're going to have to compatibilize those in order for you to make a good product. This slide is basically a little cheat sheet that I put together that you can get an idea at looking at this, what you're trying to compatibilize and what some of your potential compatibilizer options are. So if you notice for polyethylene, polypropylene blends, I've got several products checked off. You could use polyolefin elastomers, you could use olefin block copolymers, you could use a propylene-based elastomer, acrylate copolymers, or reactor TPOs. So all of those will work for you. But I would argue that based on my experience is that olefin block copolymers tend to perform the best. And the reason is, again, as a block copolymer, they work really, really well to stabilize that interface and to reduce the interfacial tension. And they work very well in polyethylene, polypropylene blends. Now, that doesn't mean those other modifiers won't work. It just means that in my experience in using some of those various products, most of the applications with PE contamination in PP, you're going to see that the block copolymer just performs better. And if we look at non-polar to polar polymer blends, we're going to need a reactive compatibilizer. So we're typically going to look at a maleic anhydride grafted product or a glycidyl methacrylate product if you're dealing with polyesters. And the last example I want to give on this slide is the next column where I have non-polar and polar materials and metal contamination. So in multi-layer film, it's not uncommon that one of those layers might be metallized. And so with multi-layer film scrap, you need to not only compatibilize the polar and non-polar material, but you may also need to compatibilize the metal. So once again, typically what we're going to have here is one of these reactive modifiers like a MAH or GMA modified. One of the things I would comment though is if you have only a non-polar material like polyethylene or propylene and metal contamination, that I would tell you that the acrylic acid copolymers will probably work as well or better in that particular situation. And so the next couple slides, I've got a number of examples to show you some of the thought process on taking a look at where you would look at compatibilizers in a different type. So in the first example, I had a customer that would receive their polypropylene or recycled polypropylene feedstock, but it had varying levels of polyethylene in it. So it made it difficult for them to formulate because it could vary greatly from load to load. And in addition to that, they were adding additional polyethylene to their formulation for some specific reasons. But what happened then is when their customers got a product that had too high of a polyethylene level in it, they started to see delamination in their molded parts. So I had suggested to the customer to look at one of these olefinic block copolymers, which again works really, really well in polyethylene, polypropylene. And in fact, they used this, it worked very well. And in addition, because this product can be an impact modifier, they were able to actually reduce the level of impact modifier while using this OBC compatibilizer in their formulation. Another good example is customers often use low melt flow polyolefin elastomers for impact modifiers. They work very, very well in polypropylene. And we like to use the low melt index materials to get the benefit of that impact modifier's molecular weight, which also helps improve impact, especially at cold temperature. However, if you get above a certain level of melt index in polypropylene, typically when you're above about a 30 melt flow polypropylene, If you recall, I mentioned that if you have too great a viscosity difference, you get more instabilities. And this is what happens as they go to higher and higher melt flow polypropylene, as your customers are demanding these higher melt flows. Using these low melt index POE elastomers causes a problem. You get poor stability, you get poor dispersion, and you end up with poor impact. So in this case, we have a special grade of a reactor TPO that makes a very, very, very good compatibilizer for low melt index POE impact modifiers and high melt flow polypropylene, like for example, a 50 or 55 melt flow polypropylene. So again, this is a case where that particular reactor TPO as a compatibilizer would outperform the olefinic block copolymer or some of the other compatibilizers I had listed on the previous page. It's not uncommon for customers to develop nylon polypropylene compounds. They take advantage of the properties and performance of nylon. They take advantage of the properties and performance that polypropylene can give them, especially reduced moisture sensitivity. But obviously, these two materials are not compatible at all. And once again, we're talking about a nylon compound. We're normally going to add a maleic anhydride grafted polypropylene, which will compatibilize those two polymers together. But once again, when we use a maleic anhydride grafted product, we are going to see a negative effect on the final melt flow of that compound. However, we can also look in a case like this of using an acrylic acid or an ionomer as the compatibilizer. And because they don't have a chemical reaction, they don't as negatively affect the melt flow index while still offering good compatibility between those two polymers. Once again, here's a case where we can utilize something a little bit different, not quite as common as the MAH grafted materials, but we can overcome some of the limitations. A lot of people make wood plastic composites, especially out of polyethylene and wood plastic and wood flour. Typically here we would add a maleic anhydride grafted polyethylene, not only to bond that cellulose wood fiber to a polyethylene, but it can also help a bit with the dispersion, because once again, it's going to reduce that interfacial tension, and that can help with dispersion, and that results in improved mechanical properties. And in this case, it's often used more as a coupling agent, really at low loading levels like 2 or 3% versus a little bit higher levels as a compatibilizer. Also, recycled polypropylene. We've had customers that have had the opportunity to get low-cost feedstock because it's contaminated with polystyrene. I had a customer that tried to make a compound out of that material. They weren't very successful because, needless to say, they're not compatible and the properties were not very good. But adding a styrenic block copolymer will, as a compatibilizer, will then improve the properties. So the styrene end groups are compatible with the polystyrene component, and the olefinic mid block in these materials is compatible with the polypropylene. Once again, they make very, very good compatibilizers for these types of mixed feed streams. I had another customer that used recycled ABS, and they would get occasionally some polystyrene contamination. And while polystyrene has some compatibility in ABS, it's not that great. And this particular customer would notice, even with very, very low levels, like 2 or 3% of polystyrene contamination, they were not able to even process the material. So once again, here's another example. A styrenic block copolymer can compatibilize that polystyrene contamination into the ABS polymer and provide a product now that has much improved properties and that you're able to process better and get better performance. And my last couple of examples, recycled polyethylene that contains PET contamination. With a lot of these multi-layer thermoforms and multi-layer film applications out there, there's a lot of different contamination that we can find in in polyethylene. We can find PET, we can find polypropylene, we can find nylon, we can find EVOH, and a lot of other things. So in this case, it had PET contamination. The customer, again, had a low-cost feed stream, but had to deal with the PET. Again, as I mentioned, the glycidyl methacrylate compatibilizers work exceptionally well with polyesters. And in this case, that's what the customer ended up using to compatibilize those two products together so that they can make their final compound. Maybe you're developing a PC-PBT blend, and once again, you're going to take advantage of the properties of polycarbonate, the properties of the PBT, and combine them into a blended material. In this case, there's a number of products we could consider. Maleic anhydride grafted materials could work, acrylate copolymers could work, but because of that polyester component, GMA-based reactive compatibilizers will outperform the other materials. And the last example, recycled polyethylene film that contained aluminum foil contamination. Needless to say, if you've got aluminum in your polyethylene, it's not going to be compatible. It's going to be a contaminant. It's going to be a cause of failure in a molded product. So in order to compatibilize that, here's an example where the acid copolymer would probably outperform a maleic anhydride grafted material to use as a compatibilizer, because those acid copolymers love aluminum and they have very, very high bond strength to that aluminum, compatibilizing your product, and you're able to make a better performing compound. And so my last slide, just kind of a summary. Polymeric compatibilizers are very effective in compatibilizing polymer blends and recycled or contaminated feed streams. In addition to that, they can act as coupling agents as well as acting as impact modifiers, and it can be overlapped in any individual blend or compound. There are a lot of different compatibilizers that are available. Which one is best for your application will really depend on the specifics of what you're trying to do. And not only that, there's a lot of other types of compatibilizers on the market. I'm primarily talking to the type that's supplied by Untitled Polymers, but there are other compatibilizers out there. And it's certainly possible there's more than one compatibilizer that could work for your application. In fact, I had a customer a few years ago that looked at 5 or 6 different materials for their compatibilizers, and the one they picked is not the one that I would have thought would have been the best for their application. However, based on the products, the polymers that they had, the melt flow of the materials, and how they were compounding those, that product performed better than some of the other ones. And once again, with the strong push for sustainability and using post-consumer recycled materials, I believe that the need for compatibilizers is going to continue to grow, and we're going to see a lot more application and opportunity for these as the quality of the feedstocks may start to go down, and we're going to see a lot more mixed feed stream recycle being used. There's going to be an absolute need for that compatibilizer. And then lastly, here at NTech, we've got a lot of experience with these different polymeric compatibilizers. We'd love to talk with you on your application, help you in getting the best one to fit your needs in your application. And you can certainly reach out to us separately if you want to have a one-on-one conversation about that. And for my last slide, this is my contact information. Again, please feel free to reach out to me if you have some questions or you'd like to discuss this in a little bit more detail on your specific application. And now I'm going to turn it over to the question and answer session. And I see that we already have a number of questions that come in. I see a question here that says, what do you recommend as a compatibilizer for TPS and PLAs? Well, I assume for TPS, you mean thermoplastic starch and PLAs. And in many cases, there's a couple of options for the PLAs. The first one, because a PLA is a polyester type material, I would recommend a glycidyl methacrylate compatibilizer for that. You could also use butyl acrylates. That's one of those acrylate copolymers. So that's another option that you can use in there. You could use, again, maleic anhydride grafted, but I would recommend that glycidyl methacrylate first for that application. And we do have, in addition to the glycidyl methacrylate and MAH modified, we do have a compatibilizer, an impact modifier for PLA materials that can actually maintain some contact clarity in PLA if you're using a transparent one. Another question, do compatibilizers affect the recyclability of the polymer blend? Once again, in most cases, it will improve the recyclability in terms of allowing you to use that material and compatibilize any contamination or mixed polymers in there. Again, most of these products, if we think of, for example, an SEBS or an acrylate for a compatibilizer, no, then it's really not going to affect that recyclability. If we look at something like an MAH grafted material, let's say you're talking about polypropylene and nylon, the level of the MAH in there is very low when you incorporate it in. And so again, it's an olefinic backbone. So generally speaking, no, that should not affect the recyclability of that polymer blend. There's another question here. What do you think is the best compatibilizer for blends of polypropylene and Ziegler-Natta linear low density polyethylene to provide high clarity, tough packaging film? In this case, I would recommend a maleic anhydride modified polyolefin, and specifically for that application, the Dow Retain material would be the specific product that I would recommend because it was developed specifically for film recycling to compatibilize dissimilar polymers, in particular nylon and EVOH, into the linear low density. So it not only compatibilizes, but it's also designed to improve properties as well as maintain the clarity. And so I think that's a key point in the question here. And I would, again, recommend the Dow Retain 3000 material for that application. Another question here, what non-reactive compatibilizer would you recommend for polyethylene and polyurethanes or polypropylene and polyurethanes? Well, for a reactive one, I would recommend one with maleic anhydride. But the question is, what would I recommend from a non-reactive? In that case, I would tend to lean toward the acrylate copolymers because they'll have very good compatibility with the polyethylene and polypropylene, but they'll also have the acrylate functionality that will work with your polyurethane. And so in that case, I would look at one of the acrylate copolymers to utilize for that. Let's see, I think that's all. Here's a few more questions. Can we compatibilize PET and PE? There are a few research studies on that saying it is possible. Is it practically possible? Yes, absolutely, it's practically possible because once again, we would utilize a glycidyl methacrylate copolymer where the backbone is an acrylate and has the compatibility actually both to polyethylene and PET. However, the glycidyl methacrylate would now be a reactive compatibilizer, and they work very, very well to compatibilize PET to polyethylene and polypropylene. Another question that came in, what is the best type of OBC you recommend for high density polyethylene and a polypropylene blend, and what is the usual loading level? The product there is the Dow Infuse OBC, and this is a polyethylene block copolymer. And for compatibilizing the high density to propylene, again, it depends a little on the ratios, but we've seen really, really good success around that 6 and 7% loading level. Once again, it doesn't mean that a lower level would not compatibilize your specific application, but generally speaking, I would tell you looking at 5 or 6% level. Let's see. What compatibilizer do you recommend for blending PVOH-based polymer with polyethylene? Once again, for this application, a maleic anhydride modified compatibilizer is what you would need. The maleic anhydride reacts with the PVOH, and the olefin backbone is compatible with polyethylene. Now, this is a specific case where if we look at compatibilizing polyethylene and PVOH, or polyethylene and nylon, for example, usually with PVOH and EVOH, you need to use a little bit higher loading level of the compatibilizer. So you might find that if you were doing the same blend with PE and nylon, if you got away with, for example, 6% loading level, you might actually need 8 or 9%, depending on the level of the PVOH or EVOH in your compound. Another question, when you mentioned the negative effects on melt index, are you saying the melt index is going higher or lower? It's going lower, because just think of as that compatibilizer reacts, it ties everything together kind of like a big traffic jam. And so what it does is it really lowers the melt flow of those final compounds. And everyone is always trying to get higher melt flows. It's not such a problem in, say, polyethylene, polypropylene, because we're not reactively compatibilizing in most cases. But for example, in nylon compounds, the maleic anhydride modified compatibilizers are the go-to, the standard product, but they kill the melt flow. And so once again, we've got some tips and tricks that we can utilize to help minimize the drastic drop in melt flow, where we're still going to lose some melt flow, but we may not lose quite as much. So it helps that end product have a little bit higher melt flow in that final compound. Can I claim 100% recycled content for PCR resins if I use a compatibilizer? Good question. My understanding is, as long as you're using less than 5% of the compatibilizer, I believe that you can still make the claim of 100% recycled content. Again, not 100% certain, but to the best of my understanding, that's the case. Another question, can you recommend some OBCs for PP, PE blends and compositions? Once again, for that, I would recommend the Dow Infuse material. And again, typical loading level for that compatibilization would be about a 5 or 6% loading level. And let's see. If you have a PET and PE with a low percentage to compatibilize, could it be the same as if you have the opposite? Yeah, so if you had, for example, if you had 95% PET and 5% PE, or you had 5% PET and 95% PET, yes, we would use the same compatibilizer. In this case, once again, I would use a glycidyl methacrylate modified material as that compatibilizer. The difference here would be if it's mostly PET, we could probably use lower levels of that compatibilizer. But if we had 95%, if we had PE with large levels of PET, we'd need to use more. If we had the large levels of PET and low levels of polyethylene, we could use a lower amount of that. Another question, can you compatibilize PE and PE? I think we already hit that question. Yes, you can compatibilize those with glycidyl methacrylates. Another question, can we get a copy of your presentation? Yes, all of the attendees will be emailed a PDF copy of this presentation at the conclusion. And I believe that is all of the questions that have come in. If there are, I'll give it a minute. If there are any other questions, if you could please get those turned in right away. Otherwise, I will say thank you for attending. Once again, we will send you a copy of this presentation. If you have additional questions that come up after the conclusion, please feel free to reach out to me. Email is usually the best way. And also, if you have some specific applications that you would like to discuss in private, then please, again, feel free to reach out to me and I'd be glad to work with you on that. So other than that, thank you again for taking the time today. I hope you found it valuable and you picked up some useful information for your business and opportunities. Thank you again.